The problem with slope point form is that we must have the slope first. If we don't have the slope given to us, we can't really create the equation. But usually in this kind of situation, the questions here will give us enough information so that we can use those information to calculate the slope of a line. Here in example number 2, we have 2 points given to us. Although we don't have the slope given, we can use these 2 points to calculate the slope. Using the slope formula, y2 minus y1 over x2 minus x1, we will have 1 over negative 3. This is x1, y1, and x2, y2. And once I have the slope, I can now create the equation in slope point form. We have the slope, and we need 1 point. It doesn't matter which point you use. We got 2 points here, and I can choose any of these 2 points to create your slope point form. So let's say if I'm to stick with the first point, y minus y1 equals negative 1/3 x minus x1, so x minus negative 5 give us x plus 5. This will be this equation in slope point form. Changing your slope point form to general form, the idea is to come up with ax plus by plus c equals 0. One important concept for the general form is that we don't want denominator. So as I multiply this denominator to the other side, 3 times y minus 2, the denominator on the right hand side will now be gone, giving us negative 1 times x plus 5. And as you open up the bracket, 3y minus 6, distribute your 3, equals negative x minus 5. I can now group all the terms together, put them on the same side, and turn it into general form. So now, if I'm to move the negative x to the left hand side, that becomes plus positive x. 3y on the left hand side, and finally negative 5, bring it to the other side, it becomes plus 5. So negative 6 plus 5 give us minus 1 in the equation. So that would be the equation in general form. Now if you sometimes when it comes to linear equation, there are times when you are just you don't know what to do with the question itself. And in those kind of situations, I would say make a sketch. When you are to plot the points given to you, when you indicate the x-intercept or the y-intercept which may be given in the questions, you will then be able to identify the slope, the y-intercept, or whatever it takes to create, and you will be able to create your linear equation. So moving on to the example number 3. In example number 3, this question looks a little bit weird. They are saying that, hey, you know what, there is a line, but this line we don't know the slope, we know nothing about it. The only thing given to us is that this line has the same x-intercept with the line here. So we know nothing about the original line. Well, the line that we are trying to come up with, we don't know anything, but they are telling us, hey, the x-intercept for those 2 lines are the same. And then they also have the same slope. Well, I know that if these 2 lines have the same slope, m equals 5. Y equals mx plus b. And I also know how to calculate the x-intercept of a line. I can substitute 0 for y into the equation, and that will give us the x-intercept. So if we have a line with x-intercept at -6 and the slope equals 5, then the line will probably go in a very steep slope and eventually hit the y-axis somewhere up there, very high. You need a very big graph to see your y-intercept, and we can probably create the equation in slope-intercept form. But looking at this picture, it is impractical to come up with an infinitely large graph paper to see the y-intercept on the graph. But I know this point. Not only is this the x-intercept, but I can consider this as a point on the x-axis. So when we have the slope and the point given to us, -6 and 0, I can now create the equation of a line using the slope point form. I have the y-coordinate of this point equals 0, and I have -6 for the x-coordinate. Here is the slope, m equals 5. So as I substitute everything into it, we will have this equation in slope point form, or if you choose to expand it, this time we have the slope intercept form.